Module 2 is named as Distributed Storage and Data Lake. Okay, and this is the session 1 for distributed storage. First of all, a quick recap of Hadoop. It has 3 components. Okay, 3 components. The first one is HDFS, and that is for storage. Number 2 is map reduce, that is for processing. And when I say storage, this means the distributed storage. When I say processing, this means distributed processing. And number 3 is yarn, which we will see most likely in module 8, yarn architecture for managing the resources. Okay, now let us talk about architecture of HDFS or of Hadoop from storage point of view. Okay, the most important thing about the HDFS is that it follows a master slave architecture. What do we actually mean by the master slave architecture? It means that we have one master node, and for example, if we have a, let me specify at the starting, we have 4 nodes Hadoop cluster, and by now you know the meaning of cluster. Cluster is a group of machines put together for parallel processing, for distributed storage. And what do we mean by the nodes? Nodes are the machines. Okay, one master node and 4 slave nodes. These names are very common names. These names are not the field specific names. When we talk in the realm of field, then this master node is called as the name node, and these slave nodes, they are called as the data nodes. So first thing to remember, when we talk about nodes in a cluster, you might have noticed one thing. 4 node Hadoop cluster means how much is the count? 4 plus 1, 5. We did not consider master node. When we say 4 node Hadoop cluster, by this 4 we refer to slave nodes only. Why? Why? Can anybody answer me? Yes, Ahmed.
जी मास्टर नोड जहाँ तक मेरी नॉलेज है लाइक ये एक रेप्लिका नोड होगी जिसपे हमारा डेटा स्टोर रहेगा.
Got it. That's also correct up to some extent. Anybody? Say 4 node Hadoop cluster or n nodes Hadoop cluster, we consider only the number of slaves. Why? Because they do the actual work. Got it? They do the actual work. Name node does not do the work of processing. Got it? Name node does the work of processing. The actual work is done by the slave nodes or data nodes. That is why we refer to this digit in the description of our cluster. Okay, this is the first thing you need to note. Now coming to master slave architecture, 4 nodes mean, let me now go to the Excel draw. By the way, I have shared with you this the link of this file. 4, what is that? Okay. This means that we have one master node. To get into details of how the data is stored in a distributed manner. Okay, this is the master node, the name node. Okay, and now these nodes are called data nodes. I'll say this data node 1, 4. Okay, now you are clear with one thing, that Hadoop follows a master slave architecture. Name node is the master node, and the other nodes which have to do the work are called the slave nodes or data nodes. They have no other name except data nodes, and this node also does not have no other name. When we talk about the edge node or client node or gateway node, it has multiple names which I have told for various times, and I'll be telling you in the upcoming sessions. Okay, now let's think we have a 500 MBs file, and we are looking Hadoop from the perspective of storage, that how the data is stored in distributed manner. What are its parameters? How we can tune its performance? These are some of the questions which would be answered once you have gone through this. Okay. So when it comes to storing, we have two ways. How much ways we have? We have two ways. This is a 500 MBs file. We need to store it, and we have 4 nodes. But we have two approaches. Case 1 is we can store this file in one node. हमारे पास केस 1 ये है, we can store this complete file. Let's say this is the file. We can store this whole file into any of the block. For example, node. For example, here we can, for example, store this here. We can store this here. We can store this here. But what is the drawback of this? Can somebody tell me what is the drawback of this? Data is stored on a single machine. This is a true replica of monolithic system. So if we are to save a file on a single node, then what is the need of other nodes? Because this truly depicts the architecture of a monolithic system, and we were having a lot of pain points from that kind of system. This means that this kind of approach does not work. This will lead to a monolithic that is it is not favorable, because we have a lot of pain points from that. Okay, if this is not the case, then case 2 is we can split this file into multiple multiple trenches in order to store it. For example, now let's try to make different in these four nodes: node 1, node 2, node 3, node 4. If we can store this in this manner, for example, we have made its four parts like that. Okay, now think of this as these are the four parts of this 500 MB files. So we can, what we can do, we can store this first block here, second trench here, I'm not fourth trench here, part, you can say part. Is there any pain point now? To me, there is no pain point. Why? Because we were having pain point from the distributed, from the monolithic system, in which on single node there's a lot of load. That is why it sometime it fails. But in this system, we have divided this file into four parts, and these four parts have been stored in different nodes. Now, if, for example, if I store this whole file in data node 4, and it takes 500 CPU cycles due to 500 MBs. Now, due to this, for example, let's divide it in this file in four parts. So we will be having 125 each. Previously, this block has to perform 500 CPU cycles in order to process 500 MBs. Now, this file has to process approximately 125 CPU cycles to process this. So look, this will be having 125 CPU cycles, 125 CPU cycles, and 125 CPU cycles. And previously, if this node only, in the case when it has all the data, would be taking 500 seconds, now it would be taking 125 seconds, 125 seconds, 125 seconds, 125 seconds. And think of a situation, they would be working in parallel. If they all are working in parallel, so total time taken is only 125 seconds. But in the previous case, when the data was stored on a single node, the total time taken was 500 seconds. So you can think that by storing the data in a distributed manner, we are talking about the uh, storage only. By storing the data in a distributed manner, what we can do, we can save a lot of time, we can save a lot of resources. And time is the best resource, by the way. Okay, I hope this is clear. So I have discussed two approaches. Now, this file has been divided into four parts. Four parts. Each part is called a block. Each part is called a block. So there is a new terminology for you, block. So this is block 1. I'll say is this as B1. Okay, this is block 1. I can say this as B2, this as B3, and this as B4. So we have four blocks. I hope you can understand. Block 1, block 2, block 3, and block 4. What is a block? The file is divided into different parts in order to be saved in a distributed manner. Each part is called a block. So I'm going to write it down here. For storing, each file is divided into parts, is called a block. Okay. We are clear till here. Next question should be, is there any default block size in
Yes,
HDFS?
128.
Default block size. The default block size in HDFS is 128 MBs, and there is a reason to it. Why is the strictly 128 MBs? By the way, admins can change it. This can be changed, but most probably in most of the cases 128 MBs of block size is followed. 128 MBs. So we had 500 MBs of file. We split this into 4 parts, and now you know the part is called a block. So how would this file, this 500 MBs file would look like? The block 1 would be 128 MBs. Block 2 would be 128 MBs. Block 3 would be 128 MBs. And the block 4 would be, how much would it be? 116 MBs. I hope this makes 500. 360, 24, 84, 16, 5. Yes. So this is the whole calculation. So now you get to know one more thing, that not all the blocks could be of the same size, but from the very first block, the blocks have to follow a size of 128 MBs. Got it? So block 1 is of 128 MB. 128 MBs. Block 2 is of 128 MBs. Block 3 is of 128 MBs. But block 4 is of 116 MBs. This is 116 MBs. I hope you can understand this. So is everything clear till now? Okay. So now if this 125 CPU cycles was just for your reference, got it? When you will build a lot of knowledge on top of that, you would feel that this is nothing. Got it? But actually this is just for your reference in order to make this concept very live for you. So I'm just removing this. Okay. So till now, what we have learned that HDFS follows a master slave architecture in which there can be one master and more than one slaves. Master is called a name node, slaves are called data nodes. Okay. And when we refer to the configuration of a cluster, we only specify the number of workers in that cluster. Why? Because they do the actual work. After that, we learned how is the data stored in a distributed manner. We took the example of a 500 MBs file in which we had 2 cases. The first case could be that we could store this file in a single machine, but this could lead us to a monolithic approach, and we have a lot of pain points from that. That is why that is not favorable. The other case is that we can split this file into different trenches or parts to store it. When we split this file into parts, each part is called a block. Then there is a concept of default block size in HDFS, and each block by default is of 128 MBs. And the perfect example was 500 MBs. This is not the case that each block must be of 128 MBs. The blocks could be of 128 MBs, but if the last block is having the memory of the storage of less than 128 MBs, it can accommodate that. What happened if we have 550 MBs of file. So we could have one more block of 128 MBs, and after that we could just subtract 128, 128, 128 four times from the 550, and the next block, which could be of block 5, it could be of, let's, for example, I'm taking 18 MBs. It could also be of 18 MBs. So please make sure that you remember this point. The block size shall not be of 128 MBs. If the block size is default size is 128 MBs, it could be less than that, but it could not be more than that. I hope this is clear. Is everybody clear till now? Was block size, and the other thing is default block size. And after that, you must keep in mind that how this file can be split. I hope this is clear. Okay. After that, what we have is the concept of metadata. Metadata. Can somebody tell me what is the metadata? Metadata is the data about the data. What is data? Data is information. Got it? So this is data about the data. Okay. Now can you think, for this 500 MB files, we have a metadata generated. How? Look here. If this is a 500 MB file and we have a metadata for that, how could it look like? Its metadata could look like, for this file, we can first of all say its metadata would be like a table. How would this table be generated? Look here. First of all, we will say file name. Okay, let's give this file a name. For example, I'll say file1. Got it? Okay, file name. Then after that, we would say block name. Think from the perspective of storage. Block name. Then think about the data node. Okay. Then think of its size. Okay. How can I justify this? What is the file name? File name is file1. Here is the file1. Okay. File1, block1. Here is block1. Where block1 is stored? Block1 is stored, look here, at data node 1. Block1 is stored at data node 1. So I'll say this is stored as at the DN1. What its size? Size is 128 MBs. Just replicate this for the other things. This is stored on block 2. Sorry, the block name is block 2. Stored on data node 2. And the file size is this. I will not be writing it for the third block. The file name is same. Block is 4. You can imagine for this table has been generated for this file. So there are two things. There are number one, the actual data. Number two is the metadata. Now the question is, what is stored where? डेटा metadata कहाँ स्टोर होता है और कहाँ स्टोर होता है? So the thing is, the actual data is stored in the data nodes. The other thing is, the meta, sorry, making a lot of mistakes today. The metadata is stored in the name nodes. Remember this point. Where the actual data is stored in the data nodes, where the metadata is stored in the name node. So I'm just taking the screenshot of this table.
Name
Suppose
node.
now I will say this stores the metadata, and I can paste the metadata here. Yes, okay, this is the metadata here for this file. Let's give it a structure of table. Let's try to give this. This could just look like a table. So this node stores only the data about the data. This tells that from this file, file 1, it's this block stored on this data node, and it has this type of size. These are not only the details, but for just for giving a simple example, I am taking only these details. There could be tons of other details stored on what rack, stored in what server, who is the owner of that, stuff like that. But this is the bare minimum information a master node could have about a file. And who stores the actual data? This is the actual data. The actual data are stored in the data nodes. That is why they are called data nodes. Got it? So I'll say they store the actual data. The actual data could be of many types. For example, let me just at these locations. Got it? Some part would go there, some part would go there, some part would go there, and some part could go there. If you can visualize this, I hope this is clear. This was the main thing about the storage purposes. How we can store this file. This is a 500 MB file. In order to store it in an efficient manner, we need to store it in the distributed manner. So we made 4 copies out of it. The first copy has not copy. We have made 4 parts of it, and each part is called block. First block is stored block 1. The other is stored on the block 2. The other is stored on the block 3, and the remaining is stored on block 4. This cannot be the case. This cannot strictly be the case that block 1 is stored on node 1. Block 1 can be stored on node 3, node 2, anything. But this is the simplest thing I could tell you about. Got it? So I hope everybody is clear till now. Once you have built a lot of knowledge on top of that, you would easily understand it. So I hope you can understand the intent behind these kind of simple examples. Okay.
बिल्कुल.
All right. So moving forward. Okay. We have seen that for a 500 MB files, for a 500 MB file, luckily we had 4 partitions, 4 blocks, and luckily we had 4 nodes, and we have easily stored each node on each block on each node. Okay. What if we have I'll first block would be block 1 could be of 128 MBs. Block 2 could be of only 22 MBs. Okay. So suppose we have, this is the block 1, this is block 2. Just referring, this is the block 1, this is block 2. Okay. If we need to store this block, we could store this block here. And if we need to store this block, we could store this block on this node. Got it? So this is dn1, dn2. Now what is the case? The case is that this is stored here and this has been stored here. What about these two blocks? I'm making them as red. Answer is yes. So we have noted one more thing, that if the file size is less, any of the nodes could sit idle. But think of a situation where the file size is greater. Where the file size is greater. I'll perfectly 1000 MBs or roughly 1 GB, you can say 1 GB. How would this scenario be? In this case, we would be having more 4 blocks. Is it so? We would be having 4 more blocks. So note one thing, that we would store this block here, this block here, this block here, and this block here. Did you observe something? If not, let me tell you. This is a discussion. File size is less or more. Okay. If this is the case if the file size is less, and this is the case if the file size is, if the file size is greater, each node could store more than 1 blocks. This concept is very important. At starting, most of the people think that each node is meant to save only 1 block, but this is not the case. As per the requirements, each node contain more than 1 blocks. And if the file size could be of 1500 MBs, so accordingly we would be having 12 blocks of that. So each node would be saving three blocks. Is it clear? Everybody, this is clear?
Yes.
Yes.
So we are studying Hadoop and we are studying HDFS. HDFS is a data lake. Look, distributed storage and data lake. So this is the reason why I am discussing these things. The main reason is that you could spend some more time on thinking in a distributed manner, thinking about the storage in a distributed manner. If you do not go into these details, your concepts would be fragile. Once you start building the further concepts, you would totally forget about this. If you don't know, if you have not thought about the storage in this detail, you would lost your memory in this case. So I hope you can understand the point, that why are you being taught these points. I hope this is clear.
सर, और एक ब्लॉक में हम कितने एक नोड में हम कितने ब्लॉक्स मतलब ऐड कर सकते हैं, ये डिपेंड करता है फाइल साइज में?
First of all, this is a good question. I appreciate memory card hub. For example, you have a 4 GB of memory card. How much maximum data can you store in it? So you cannot exceed the size of it. So each node has, what is a node? Node is a machine, and machine contains resources. It contains resources means it contains RAM, it contains the storage. So we can store the data up to the level, up to what level? The level of its storage. If the node has the capability of storing only 4 GB, so we can contains the block which can exceed up to 4 GBs, not more than that. This is logical. Is it clear?
Yeah.
Moving forward, the main thing. Did you notice that the block size is 128 MB, default block size? Why? Can somebody answer me? Ariba, can you answer us? Why is the block size, default block size 128 MBs? Why is the default block size of 128 MBs? Okay, is correct. Let's discuss. Yes, please. 500 MBs file. This would be the simple example. And according to 128 MBs, we would be having 4 blocks. Okay. Scenario. We are increasing the block size. Increase the block size. Okay. For example, if the just a second, please. All right. If we have 256 MBs of block size, then how much blocks we would be having? 2 blocks. Let's take this example for 100,000 MBs file, and according to that we would be having 8 blocks. If we increase the block size to 256 MBs, we would be having 4 blocks. If we go with 512 MBs, we would be having 2 blocks. If we have 1024 MBs of block size, we would be having only 1 block. Okay. There are 2 aspects of it. One thing increases, but the other decreases. What is that? In this case, what increases? What is increasing here? In this case, look, the block size is increasing. The block size is increasing, but the blocks are decreasing. Ultimately, this system would replicate to a monolithic system, isn't it? If we have 1024 MBs of block size and we have a file of 100,000 MBs, or we have a file of 500 MBs, then this would only make 1 block. Can we store 1 block on more than 1 nodes? Part of file which is meant for storing, and if we have only 1 part, so this would become a monolithic system. So that is why we do not increase the block size. Okay, so can we decrease the block size? Decrease the block size. Let's see this. If we decrease the block size, for example, for this file, we have initially 8 blocks. But if we are doing it on 128 MBs, the blocks are 8. If we decrease this to 64, we will be having 16 blocks. If we decrease to 32, we will be having, I think, 32 blocks. If we decrease it more to 16 MBs, we would be having 64 blocks. Sorry, is it so? Now there is one benefit, but one very strict drawback. What is that? The benefit is that block size are decreasing, and for each node, for each of this node, it would be very easy to process it, isn't it? We would get performance benefit at the data nodes level, but we are missing on very important thing. The important thing is, for only 4 blocks we have that much of tables. Now think this, if we have 64 blocks, how much huge table would we would be having? In this case, what I mean to say, in this case, the metadata increases a lot, which puts pressure on name node. And now you would think this is as compared to big data, this is very less amount of data. The metadata, I'm talking about the metadata. If we have metadata about 64 blocks, it would be very less. But name node is not meant for processing. It is meant for coordination. If we have 64 blocks, and if we have a lot of metadata about them, then it would be difficult for master node to communicate effectively. And ultimately, all of these slave nodes report back to this master node, and its result goes to the client machine. If this is down, and these are up, and this is the source which gives the output, would we be able to get the output in an efficient manner? No. So decreasing the block size is also not favorable. Therefore, we go with 128 MBs. And this is not a divine number. Got it? This is not a revelation to anyone that, we should be going with 128 MBs. This file size is a moderate one. And yet we have performance issues with this file size. Because if there are 100 blocks, then this, if according to this block size, we are having 100 blocks, we still be having a lot of metadata. Got it? So, but we have to come to a number which is a moderate. Got it? Which not only avoids us from getting closer to monolithic approach, and not only it gives us the less metadata. Got it? So this is the main thing. The whole agenda of 128 block size is that it is a moderate one. It only gives us the performance benefit. I hope you can understand this. Is it clear, everybody? Till a point where we have seen that this 128 MBs of block size is a favorable one. On one end, it generates a moderate level of metadata, and on the other end, it avoids us or it prevents us from going to the monolithic approach. So I hope everyone is clear till now. The efficient big data systems has one very important attribute. And what is that? Apart from storage, apart from processing, they have one more thing. They have the scalability factor. So while hearing the word scalability, you can think of two questions. Can we scale at name node level, or and can we scale at the data nodes level? And why do we even need got it? Why do we even need to scale? And what do we mean by the scale? Scaling mean increasing the resources. I hope this is clear. So we can scale at name node level. There is a concept of secondary name node. Why is it needed? Look, when the metadata increases, and if all of that metadata is stored onto that single name node, it puts pressure on it. So for that, there is a concept of secondary name node. Why do we need it? If the metadata becomes too huge, we could split this metadata into two name nodes. Think of a situation where there are some sales tables. So they would generate sales metadata. And on the other hand, there are the what can I say, marketing tables. And they are generating marketing metadata. So what we can do, we can store one type of metadata at name node 1 and the other type of metadata in the name node 2. Because if we store the same or the accumulative metadata on a single node, it would put a pressure in it. So the whole purpose of secondary name node is to split the metadata in order to prevent putting a pressure on the single name node. And this concept is also called the name node federation. Federation is an entity which can act independently. Got it? So there would be one federation which would be holding the metadata about the sales table, and there would be another federation which would be containing the information about the marketing tables. So I hope this is clear that what is the point of secondary name node or the name node federation. There is one more purpose. Let's first talk about, can we scale at the data node level, and why do we need? I'm just putting this under can. Yes, we can. Why do we need it? Why do we need it? When more data comes in. Currently, we will be having 500 GBs. In the next month, we might be having 1000 GBs. For this remaining or the added 500 GBs, we would be needing more machines. So we would be attaching more machines at this level. So I'm just copying this and pasting it here. More master nodes. And we can also have more data nodes. I hope this is clear. So at name node level, yes. If we scale at the name node level, the whole purpose is to prevent putting pressure on that node. And if we need to scale at the data node level, the whole purpose is to increase the scalability. The whole purpose is to entertain more incoming data. So I hope this is clear.
Yes, sir.
Yes, sir.
All right. Good question. And I got your point. Look, this is not something very strict that we would be needing only to increase the name node. And this is also not strict that we would be needing to increase the data nodes. We can independently or separately increase one thing, or we can simultaneously do one thing. So uh, this becomes clear when we are into some situation. ठीक है, जब जरूरत पड़ेगी, for example, if we have a lot of metadata, so we could go with an added name node. Or if we have more data coming in, so we would be needing data nodes. And if the data nodes are being added, it means more blocks are being added. So if more blocks are being added, it means that more data metadata is being generated. And if that added metadata is able to be stored on the name node without affecting its performance, then it's fine. But if it's affecting its performance, we could add more name node to that. Is it clear?
Yes, got it.
Is situation specific. Okay. We have not talked about one thing, and that would be the last thing for today. This much detail about the storage is enough. Do not go more deep that how is this decided, how the block size is decided, the stuff like that. Don't go into that detail because these things are now outdated. What is not outdated is the thought process of when a file comes in, then how it is stored. Is it clear? I'll tell you one thing. I have a file of around 1 GBs, and I'll tell you what number of partitions it have. Got it? So the session is getting longer. Now discuss one thing, and that is the disaster. Each system is prone to disaster. Each system is vulnerable to disaster. What kind
Like
of
the fault
disaster?
tolerance.
G, tolerance. Look, most of the times, I still remember when I bought my very first PC back in 2007, I think, and that was Pentium 2. After some days, any of these nodes could fail. Any of these nodes could fail. Then what? For example, let me just make a copy out of it. I'm not good at drawing. Okay. I think drawing is a thing that is more specific to girls. They're generally good at drawing. We boys, data node 4 fails. And for example, we have, think of a situation, we have 4 months of data. We have 4 months of data. Jan, Feb, जन को हमने सेव किया dn1 पे, Feb is stored, and we have lost dn4. It means the April data has been wiped out. We are not able to retrieve that data. Is this a good approach? No. For this, we make multiple copies out of it. Let me write it here. Any of the data nodes could break out or malfunction. In this case, we will lose all the data. In order to prevent that, we make more than one copies of that data and store it into more than one nodes. How? Look here. We could store block 1 on data node 3, data node 4. And if, let me just have this file. We can store it here. We can store it here. And we can store it here. If this node goes down, if this node goes down, what would happen? We are able to retrieve its one copy from this node, one copy from this node. For example, for another block, we would repeat this process. We would store one copy here, one copy here, and one copy here. If we still lose any of the data node, we are able to retrieve its single copy from any other data nodes. So the whole process is repeated, and this is done only to prevent data loss. And this process is called fault tolerance. By this way, we tolerate the fault. What kind of fault? We could lose the data, or any of the data node can go down due to any software issues as well. If the software is not running properly, it will not give us any hint. Got it? So the fault tolerance is the new concept or the new terminology you should keep in mind. Is this done? This is done in order to prevent the data loss. The same thing can be done on the master node as well. If any of the master node fails, then what could be the case? We can store the copies of metadata into another master node. Is it clear? You would learn those things when you get into those details. Got it? But for now, keep understanding these points so that your understanding of storage can become solid. This is all from this